Let's look at minimum operation in Python.
Okay, guys. Today I want us to solve this problem together. This minimum operations problem. So it says in a text file there is a single character h. In your text editor can execute only two operations in this file. The two operations are copy all and paste. And given a number n, write a method that calculates the fewest number of operations needed to result in exactly n of h characters in the file. Then the program will return an integer. Then if n is impossible to achieve, should return 0. So let me try to explain this. So this minimum operation is we have a text file that initially contains a single character h. So and the text editor can perform two operations. Copy all, which is we can copy all the characters in the file. Then paste, we can paste the characters you copy. The goal is to determine the minimum number of operations needed to have exactly n of h characters in the file. So we start with one h, and you can only use the copy and paste operation to create more h characters. So let's say n is equal to 9. So initially we have one h in the file. So we can copy it, making it HH, and then paste it, making it HHH. Then you can copy the HH to make you have 4 of H, then paste it to have HHH. So just like that, you can continue until we have 9. How many do we have here? Say 9H. So you can see in this operation, think about operations being 9. We define the function, and then we return 0 if n is less or equals to 1. This implies that since we already have either 0 of h characters, so means 0 operations needed, or just one h character in the file. So achieving these numbers of h characters doesn't require any copy or paste operations beyond what's already present. So the function returns 0 operations in this case. Next, we initialize a divisor variable and give it a value of 2, because we are going to start by taking the divisibility by 2. And then we initialize a number of operations with the value of 0, because at the start of calculation, no operation have been performed yet. And then we will use this number of operations to keep track of the total number of operations that we've performed. Then we initiate a while loop that's going to continue as long as the value of n is greater than 1. Then within this while loop, we check if n is a multiple of divisor. So if the condition is true, it means that we can achieve some progress towards the goal of having n of h characters by using divisor as a factor. So we update n by dividing it by the current value of divisor, which is initially set to 2. So if n is divisible by the current divisor, it means that we can achieve progress by copying and pasting divisor of h characters to the file. For example, if n is 8 and the divisor is 2. It means that we can copy and paste 2 of each characters at a time, and then n will be set equal to 4. That's 2 divided by 8, 4. So this represents the fact that after one copy and paste operation, we have 4 edge characters remaining to reach the goal. So next, we update number of operations variable, which keeps track of the total number of operations performed by achieving the goal of n of edge characters in the file. The number of operations represents the total number of operations performed throughout the execution of the algorithm. It is initialized to 0 and is updated as the code progresses. So this part, the expression, it calculates the new value for number of operations. Since this is 0 initially, and then divisor is 2, which means 2 plus 0. For the first loop, number of operation is going to be 2. Then if 2 can divide the next value of n, it means number of operation is going to be 2 plus 2. So the purpose of the whole line is to increment number of operation variable by the number of operations required to use the common divisor when n is directly divisible by divisor. So for the else, if n modulus divisor is not 0, it means if the divisor, if the remainder when the divisor divides n is not 0, we increment the divisor by 1 and try dividing it again. So then we return the number of operations. Let's set n equal to 12 and print. Let's just put in all this print statement to help us. So let's run the program. So we can see that here we initialize n to with the value 12, and then we pass it to the function. N is greater than 1, so we move on to a divisor is 2. Number of operation is set to 0. So since n is greater than 1, now we check that the divisor is able to divide n without remainder, because divisor is 2 and n is 12. So we print out the divisor here, so that the divisor is 2. So when the divisor divides n and we set it to n, see that n becomes 6, and then we set the number of operations by adding the number of operations, which is 0, plus divisor, which is 2. Now the number of operations becomes 2, and divisor is still 2. So we check if n is greater than 1. N is 6 and is greater than 1. So we go back to the loop again and check if 2, since the divisor is still 2, if 2 can divide 6, yes it can, without remainder. Then again we print out 2. Then the divisor, which is 2, and n is 6. 2 divided by 6, n becomes 2. N becomes 3, sorry. So here n becomes 3. And then since the divisor for the second loop is 2, so number of operations is 2 here. Let's see, so it's going to be 2 plus the current divisor, which is 4. So in the second loop here, number of operations becomes 4. And then n is 3. Then we go back here, you check, is 3 greater than 1? Yes. Then we check, can 2, which is divisor, divide 3 without remainder? Is no. So we skip this part and come here. Then the divisor, which is 2, we increment it by 1, it becomes 3. Here we print divisor after increment. We see that the divisor after increment becomes 3. So we go back to the loop. N is still 3. Is 3 greater than 1? Yes. Now don't forget that divisor is now 3 and n is 3. So can 3 divide 3 without remainder? Yes. So divisor is 3. And then n is 3 divided by divisor, that is 3. Now n becomes 1. So number of operations, don't forget the number of operations is 4. So now that n is 1 and the divisor is 3, so number of operations is 4 plus the current divisor, which is 3, it becomes 7. So since n is now 1, since n is now equal to 1, we go back to the loop. Is 1 greater than 1? No. So we break out of the loop and then it returns the number of operations, which is 7. That is it, guys. If you find this video helpful, please like and subscribe. Please like and subscribe.